Hello friends, this is Sumit Kumar Bharti, first year student of NIT Patna, and now I am going to start a new topic named mechanics. It is the second chapter of class 11th, and let's start. First of all, we will know about the mechanics. What is mechanics? Mechanics, the branch of physics in which we study or deal with the motion, its causes, and its various aspects. So mechanics are basically divided into two parts, kinematics and dynamics. Here two parts are kinematics and dynamics. Kinematics is the part of the mechanics under which we study about the motion of the body, and dynamics is also the part in which we study about the motion of the body. But what is the difference between kinematics and dynamics? The basic difference is the cause of the motion. In kinematics we deal the whole motion without knowing the cause of the motion, but in dynamics we study about only the cause of the motion. Kinematics and dynamics, these are the two parts of the mechanics. Let us start with the kinematics. There are some special terms which we'll use in the entire physics. The first one is particle. Particle is what? Particle is generally used in physics in the place of the body, just to resolve the significance of the dimension of the body. As the particle is a point, it has no any dimension, it has only the significance to dissolve the dimension of the body. We will, in place of body, we will use what? Particle. Second thing, we will know about what is distance. First of all, distance is an scalar quantity without any direction. It is the actual path length. What is distance? It is the actual path length covered by the body from the initial point A to the final point B. This path length will be what? Distance of the body. It is the scalar quantity and its unit will be what? Meter. Now we will study what is displacement. Distance and displacement both are interrelated with each other. Displacement is actually the shortest path length between initial and final position of the point. Let us consider this. A body started from point A and end its motion at point B. So what is the shortest possible path? This straight line, this is shown here. This straight line will what? The length of this will give the magnitude of the displacement, and its direction is in a specific direction, which is this. So it is a vector quantity whose direction is from the initial position of the body to the final position, and it is the shortest distance covered by the body from initial position to final position. Its again unit is SI unit is will be what? Meter. So you can understand it with the graphical concept here. Initially, let us assume the position of the particle is at point A, and it starts to moving and reach the finally at point B. So the position vector of initial position vector will be R initial, and the final position vector will be what? R final. So what is the difference? R final minus R initial means this is the vector, this is the displacement vector. So by triangle law of addition we can write it what? R initial plus displacement vector is equal to R final. R initial plus displacement is equal to R final. So here you can see displacement will be what? R final minus R initial. So it is the vector formula of what? Displacement. Okay, let's. Here you can see the example. It is an example given position vector in the terms of what? Time. T I cap plus T square J cap minus 3T cap. It is actually what? The position vector, which is the function of the time. Means if the time change, the position change. Means here the body is in what? Motion. So what we have to find? We have to find the displacement of the body from T is equal to 1 second to T is equal to 2 seconds. So we will firstly find what? R initial, then we will find R final, and then finally differ R final minus R initial to find the displacement. So R at time T is equal to 1, we will put I cap plus J cap minus 3K cap. Similarly, R at T is equal to 2 second will be 2 I cap plus 2 chi square 4 J cap minus 3 into 2 6 K cap. So it is R final, it is R initial. You can just difference R final minus R initial to find the displacement of the vector. So simply difference it and find the displacement. Now if you have to magnitude, under root 1 square plus root 1 square plus 3 square plus 3 square, and that will the magnitude of the displacement. Okay, now we will study out the concept of speed. What is speed? Speed is actually what? It is the rate at which the position vector of a point change. Just understand it here. Let us consider this point Okay, this is its position vector r. If the body start to move in any particular direction, let us in this direction, so its position vector start to changes. The rate through which the position vector changes, the rate through which means dr by dt, रेट थ्रू विच, दैट इज नोन एज व्हाट, क्या उसी को हम लोग क्या बोलते हैं, वेलोसिटी और स्पीड, डी आर बाई डी टी. Velocity and speed both are differ. Speed is actually the scalar quantity while the velocity is the vector quantity. But what is speed? Speed is just the magnitude at which the body travel its distance, the rate at which the body travel the distance, and its SI unit is meter per second. So speed are basically divided into average speed and instantaneous speed. Average speed and first of all you know about the instantaneous speed. What is instantaneous speed? Means the speed of a body at a particular instant of time. Means let us assume a body is during its motion. So let's understand what I want to say, that body is whenever any vehicle is just moving from one place to another place at any instant, at t is equal to 5 seconds, at t is equal to 1 second. If you want to know the speed, we just show the speedometer and can easily detect the speed. So the instantaneous speed is the speed of the body at a particular instant, while the average speed is differ from the instantaneous. Average speed is just find between the two the position initial position and final position, and it is equal to the total distance divided by total time taken. Means total distance here is AB and total time let us t, means x is the distance by meter, total distance by total time. We can understand it with an example. Let us consider the initial position of the body is A and it reaches to point B, and then again start its motion to find point C. Initially it is at 8 am at point A, 9 am at point B, but it resides half an hour to rest here and again start its journey and finally reach here at point C. So what will be the average speed? Average speed is actually only defining between the initial position and the final position. So average speed will total distance by total time taken. Total distance here is 20 meter plus 30 meter, which is 50 meter, divided by total time taken. And here initial time is 8 am, final time is 10 am. We not consider what is just between point A and point C. Whatever we either it is rest here or sometime its speed decreased. In case that's not matter. The thing which matter is the difference between the initial position and difference of the time between the initial and final position, that is 2 hours. So simply we will just divide it by 2 to find 25 meter per second, and it is the average speed of the body. Now we will study about the average velocity. So friends, here we will study about the average velocity. Average speed is what? Total distance by total time taken. In average velocity, it is total displacement, net displacement by change in time, is time taken to change that displacement. Let us understand it with an example. Let us body start its motion from point A, reach point P, and then finally reach at point C. So the time taken by the body to reach point A to B is T1 and finally B to C is T2. So what is the displacement here? Displacement here is from point A to C in this particular direction, A to C, this is the direction. So here the displacement is what? 5 meter, and total time taken is what? 2 plus 3 means 5 seconds. So average velocity will be what? Average velocity, this is average velocity since it is a vector quantity, and this is average speed, V average speed, V average velocity, total displacement 5 by total time 5, it is equal to 1 meter per second. But if you have to find average speed, then total distance will be what? 3 plus 4 7 by total time 5 seconds. So 7 by 5 will the average speed of the body. Okay, and this is all about the average velocity and average speed, and what is the difference between both. And instantaneous velocity you can also see here. Let us consider the body is traveling in this path. So if we have to find the velocity at any particular instant, this is the point. Here the velocity of the body is in the direction of the tangent, from tangent of this arc. This will give you what? The direction of the instantaneous velocity, and the magnitude of the body and the magnitude of speed at this point will give you what? The magnitude of that velocity. Okay, so it is all about the instantaneous velocity. Now see this. In general, in whole physics, R is generally used for the position vector or displacement vector. R is the notation of displacement vector or position vector. What is velocity? Velocity, as I described earlier that it is the rate of change of the position vector, as I have described. R initial and start to move, body start to move, so the rate through which this vector, this particular vector, the rate through which this swept the area will be what? The velocity of the body, means v is equal to dr by dt. It is the differential form of the velocity in the form of position. Okay, so acceleration is what? Acceleration is rate of change of velocity, dv by dt, rate of change of velocity. Okay, so it is all about instantaneous velocity and its differential form of velocity and acceleration. So here you can again see another term, average acceleration. What is average acceleration? Just like average velocity change in displacement by time, average speed change in speed by time, change in position by time. Similarly, average acceleration change in velocity by change in time. So let us consider it with, here the initial velocity of the body is v initial and final is v final, whatever with the direction, maybe it in this direction, this in. So what is the change in velocity? V final minus v initial. V final minus v, delta v is defined as what? V final minus v initial vector. It is the difference of the two vector, v final vector minus v initial vector. It is delta v by change by total time to change this velocity, delta t. So average acceleration is delta v by delta t. And instantaneous, you can at any particular instant particle, the acceleration of the body will give you what? Instantaneous acceleration. So let us understand it with an example. Initially body is going towards the north with a speed of 10 meter per second. This is its initial velocity, and after 5 seconds it just moved toward the right. So v final will be what? 10 meter per second. So we have to find the average acceleration of car in these 5 seconds. So what we have to do? Average acceleration change in velocity by change in time. So it is the difference of velocity, v final minus v initial. V final is in this direction and v minus v initial, it is v initial, so negative will be just oppose the sign. So this will be the resultant. So under root v initial square plus v final square, that is the under root 10 square plus 10 square. This is the magnitude of change in velocity by total time taken is 5 seconds. So simply divide 10 root 2 by 5, that is 2 root 2 meter per second square. So it is the what? Change in velocity divided by time. It is not the change in speed, because if we will have to find the change in speed, there is no any change in speed. Again 10 meter per second, again 10 meter per second. So change in speed is 0. So we have find the acceleration. Acceleration is actually the change in velocity divided by change in time, not the change in speed divided by change in time. Okay, so this point you must remember. Okay, let us see. Now we have familiar with some of the terms like distance, displacement, speed, velocity, acceleration, how instantaneous acceleration, average velocity, average, and that's all. So now we'll study about the motion of the body. What do you mean by the motion? If the position of any particle change with time, then we will say that the body is in motion with respect to that reference. Rest and motion both are the relative terms. A body may be in motion with respect to first reference and maybe in the rest with respect to the other reference. So overall motion is divided into two parts, uniform and non-uniform motion. What do you mean by uniform motion? Uniform motion, whenever the distance traveled by the body is equal in equal interval of time, then the body is said to be in uniform motion. Means in first second if it travel 5 meter, then again in next 1 second it also cover 5 meter, again in 1 second it also cover 5 meter. So its speed is its motion is said to be what? Uniform motion. And what is the practical example? If practical example of uniform motion, the practical example is what? If the body is moving with a constant speed, if a body will move with a constant speed, it definitely acquire equal distance in equal interval of time, so it will be said to be in uniform motion. But what is in the case of the non-uniform motion? It is the general motion which we use daily in our day-to-day life. Whatever the motion we possess is not constant. Sometimes it just increase, sometimes it just decrease. So it cover unequal distance in equal interval of time. So you can see here with an example, this both are of same length and we just divide it into equal part. In this case the body from this point to this point take 1 hour, and again in this point to this point take 1 hour. So equal distance in equal interval of time. So here we can say the body is in uniform motion. But What about the non-uniform motion? It is also divided into two equal parts, but from this point to this point it take half an hour, but this point to this one 1.5 an hour, so it is definitely in non-uniform motion. But here we can also say that between this point to this point the body speed may be changed, so we cannot definitely say that the motion in this case is uniform motion, because it may be from this point to this point the speed may be changed. So in this case also we can't say that the body is in uniform motion. For the uniform motion, the only condition that is need is the constant speed. What is the constant speed? Which I have mentioned here, means 2 meter per second is the speed, so the 2 meter per second will be constant without changing. That then and there we will show that the body will be in what? Uniform motion. Okay, so on the basis of the dimension we will now proceed toward the next lecture. On the basis of the dimension, the motion is particularly especially divided into two dimensions. First dimension 1D and 2D motion. We will study on 1D motion and 2D. First of all, you must know about the what is the dimension. 1D dimension means there is only a single direction, either it is in x-axis, either it is in y-axis, either it is in z-axis, either it is in a particular direction without changing its direction. Then we will say what it will be in 1D motion. But if the body is moving, but what about the 2D motion? If the dimension both x and y change during the motion of the body, then it is said to be what? 2D motion. We can understand it with an example, that let us we project a ball from this point, so it will cover this path. This is what? Projectile path. In this motion, the x component of means can say the body is moving toward x-axis also, and also its position change in y-axis, means here the change of the position in both x and y, both dimensions, so it is known as what? 2 dimensions. So on the basis of the dimension, there we will study of the 1D motion and 2D motion. So first we start what is 1D motion and its practical example and how to solve the problem. Then we will study about the 2D motion, which is especially known as projectile motion. So let's proceed forward. So here you can see what is 1D motion. 1D motion in 1D motion I already have said that the direction must be constant without changing. So let us proceed. This is the particular direction in which the body is moving without changing its direction. Yes, speed may be changed. Means what I want to say, yes, your speed may be change in this particular direction, but the direction not change, because that will not in the 1D motion. Its dimension is fixed. So let us assume that the initial position of this point is this point A and the final is point B. Initial velocity is u and the final velocity will be v, and A is what? Change acceleration, and A is acceleration, and the distance between the initial position and final position is s, that is displacement vector, and t is the time taken by the particle to reach from point A to B, or can say to change the velocity from initial velocity to final velocity. Here is not the final position. Here is just we assume a point where the velocity change to v. So let us take we have already studied out this equation in class 10, that v is equal to e plus at s is equal to ut plus half at s. So I just revise it. E is for initial velocity, v is for final velocity, t is for time, a is for acceleration, and s is what? Displacement. So these are the 4 equations which you basically use for the problem solving purpose. But what is the significance? Let me clear it with a particular equation just like this. S is equal to ut plus half at t square. What it want to say? It want to say that the initial velocity of the body is u, and it start its motion with an constant acceleration a. So what will the displacement of the body if after time t? That will give the displacement s. S is equal to ut plus half at t square. Okay, so let us take an example. This is the wall, and a bullet is just projected from this point, and it enters in the wall, and finally its velocity become 0 after 10 centimeters. So here the question is asked that what is the time taken by the body to take rest, taken by the bullet to take rest. So initial velocity is 150 meter per second, final velocity is what? 0, and the displacement is what? 10 by 100 means 0.1 meter. So we can find the time easily by using what? This formula. V plus u by 2 is equal to x minus display. X minus x naught is what? Displacement. Final position minus initial. X is final position minus initial. V plus u by 2 is equal to displacement by time. So just put the formula here and we can easily find that is 1 by 750 meter per second. So in this particular we have to use this four formula for problem solving. Okay, so let us proceed our lecture. Here you can see the second aspect of the 1D motion, which is motion under the gravity. Motion under the gravity means a body is either thrown vertically upward or to drop from this point to downward. Means here the direction is constant, that is vertically upward downward direction. Their direction is not the change. So it is also a concept of 1D motion, means motion under the gravity. And the why it is said that it is motion under the gravity, because the only force acting on the ball during the whole motion is what? Gravitational force. So it's known as motion under the gravity. So let us consider the first aspects here, in which a body from the ground thrown with a velocity, initial velocity u, and we have to find what is the maximum height traveled by the maximum height, means the height at which the finally the body gets stopped. What is the time taken to reach the highest position, and what is the total displacement, means what is the maximum height traveled by the body to finally reach the topmost point. Okay, so let's take the example. First of all, we will find the time of ascent, means this is the time to reach this body from this point to this point, means to the highest point. That is known as what? Time of ascent. So you can see here what is given. Initial velocity u is in the direction, and one thing which you must remember, that during the entire problem of motion under the gravity, or any or even in 2D motion also, during the gravity, the gravitational force always acts towards downward. So here the problem which the most of the student face to take the direction when we will take positive and when we will take negative. So make this point very much clear, that whenever you must take the positive in the you can take any positive in any direction, but for your reference you can take positive direction in the direction of the motion, and all the physical quantity which is opposite to the direction of the motion it should take negative. So we will use this concept here. For the time of ascent, let us assume initial velocity u, final velocity we know is 0, and acceleration due to gravity as we know is in the direction of negative, downward direction. So acceleration of gravity will be what? Acceleration will be what? Minus g we will take, because initial velocity also 0, also in upward direction, final velocity is 0, and now we have to find what? Time. So simply use v is equal to e plus a t. So t is equal to what? V minus u by a, 0 minus u by minus g minus, and t is equal to u by g. So it is the time of the ascent. So you must remember this formula whenever any body thrown with initial velocity u towards upward. So the time to reach its maximum point or time of ascent is known as is equal to what? U by g. Now the second case, what is the maximum height attained by the body? So you can see here the initial velocity is u, final velocity 0, and acceleration again is minus g. So by simply using this using the equation of the motion, v square is equal to u square plus 2s, where s is equal to where s is what? Height, and you can just solve the problem, and h is equal to u square by 2g. So you must remember this formula, because this may help you during the problem solving. You can save your time whenever you solving the problem. Okay, so this is all about the motion under the gravity in vertically upward direction. Now we'll study about the vertical downward direction, so you can understand it with an example which is given here. This is, let us consider a body at a particular height h, and simply it's dropped. So initial velocity will be what? Here 0, no any force, simply it drop, means free fall. So initial velocity is 0, and it hits the ground with a final velocity v after traveling a height h, and the time taken by the ball to reach from this point to this point is what? Td. So you can see here u is equal to 0, acceleration is equal to g. Here all the direction, here the motion of the direction is in downward, so I take all these are in positive, because the acceleration due to gravity is also in downward direction, initial velocity also, final velocity also. So we take all these positive. E is equal to 0, h g, s is equal to also h. But if you have to take in upward direction, then we will take what, s is equal to minus h. But here in the case the displacement is in downward direction, so s is equal to plus h. So it can easily be solved by v square is equal to u square plus 2s, and we will find that v is equal to under root 2gs. So you need to at least remember this formula, that while throwing upward, there are two time of ascent u by g and h equal to u square by 2g. Similarly, when body is dropped from a height h, so the velocity with which it hits the ground is under root 2gh. Similarly, what is the descent time, means time taken from reach highest point to this point, this time of the descent. You can use this by v minus u by a, so it will be under root 2h by g. And after solving, when we will relate both time of ascent and time of descent, we will find that both are equal. How we will find? Just put the h is equal to u square by 2g in this formula, and finally we will find time of descent will be u by g. You can do it by yourself, and you must remember that time of ascent and time of descent always be equal, either in the 1D motion or either in 2D motion when the body is performing projectile under the gravity. Okay, so time of ascent is equal to time of descent. It is all about the motion of the gravity. So you can take a screenshot here and just revise your concepts. Okay, so let us proceed our lecture. So in next lecture we will discuss about the 2D motion, in which we will study about the projectile motion, its various aspects. It is the most important, it is one of the most important concept, which is very interesting. So just wait for the next lecture. Thank you very much.